Thank you for being here. It's kind of hot, right? I'm going to talk about continuous deployment with the Google Container Tools. But before I do that, let me introduce myself. OK, something is broken. So I'm David. I'm a developer advocate at Google Cloud. I work in Paris, France. I used to work at Docker. I worked on Docker Desktop. And I like to focus on everything that's related to developer experience. And I love cats. So continuous deployment. We could talk about for hours, right? I'm just going to focus on a few steps like development, building images, and deploying those images to Kubernetes. There's much more to talk about, but I'm going to focus on that. So what is it like to be a developer in a Kubernetes world? Are there any developers here? Yeah? Working with Kubernetes? Yes? Do you like it? Yeah, like that? Yeah. Like, this is fine, OK? This is fine. The house is on fire. We have to use like thousands of tools. We're going to add like layers on top of layers and complexity on top of complexity, but this is fun. I'm going to try to present you a few tools that can help you reduce that complexity and that can help you have more fun. But before I do that, let me show you what is it like to be. No, we can skip this one. Let me show you what is it like to be a developer in a Kubernetes world. OK, something is buggy on my machine right now, so I'm going to try to fix it right now, because otherwise it's going to be a pain. It's super slow. So, OK. I'm going to try it, but it's super slow. Can you read the screen? Yes? OK. So here I've got a small Go sample. It's like the minimal hello world written in Go. And usually when I want to develop on that code, I would start by doing go run and see the application running locally. OK, so there's something really broken on my machine. So, sorry. It's super slow. So I'm going to demos. You know, I was there just before the talk, and I tried it, and it worked very well. And now I have like everything is like broken. I don't know why. Ooh. It's going to be fun. Yeah, kernel task 500%. 700%. OK, let's try to restart Docker. Oh, OK. It's going to be super fun. Sorry. Let's cross fingers that this is the problem, because otherwise I'll have to reboot my. Ooh, 1000%. OK, maybe I should just restart my machine, right? Yeah, I'm going to try to just restart my machine. This is going to be fun. So the rest of the presentation is going to be very fast, right? Because I have like 5 less minutes. Hello, we're having fun, right? No stress at all. It's restarting. Restarting. Can you feel the stress a little bit? Okay. Oh, yep. Okay. Doesn't look good. It doesn't look good. Okay, it's gonna be challenging. So my machine is using 1000% CPU. I have no idea why. I'm gonna try to do the presentation anyways. If you have any idea, anything. Antivirus, I don't have one. Sorry? Yes, I guess it's too hot, but I don't know how to throttle it. Do you have ideas on how to, yeah. I guess it's too hot. I guess it's the problem, and I don't know how to fix that. So we're gonna see. That's fun. So I was saying that usually I would just do go run, and it would run usually in 1 second, but here we have a big problem. And then I would try to containerize that code. And so I would write that kind of Docker file. This is the minimal Docker file I would write, and this would help. Oh, okay, it's not going to work. It's not going to work. Sorry? Sorry? It's going to be fun. It's super hot. Oh, we're dead. I love that. So, I did this presentation like maybe 40 times, right? And never have I had this problem before. So that's fun. So let's try to do a Docker build. Docker build. No way. It won't work. OK. Totally without any idea. OK, so I don't know. I'm going to talk about the product I wanted to show you without any demo. And since all my presentation is made of demo without any slide, it's going to be challenging for you to understand. But anyways, so usually I would Docker build my image, and then I would deploy it to Kubernetes. So I've got here the smallest YAML possible to deploy it on Kubernetes. So I would do something like kubectl apply the pod, and it would work. But to make sure it works, I would have to kubectl logs to see the logs. And then, since I'm a developer, I want to change the code. So I change the code, and what I would do is I would have to rebuild the Docker image. I would have to maybe give it a different tag, and since I changed the tag, I have to edit my YAML files, change the tags, reapply those YAML files, send them to Kubernetes, and boom, it's deployed. To make sure it's deployed, I have to kubectl the logs, and I can see the logs, and I can see the code that was updated. So this is the loop that I call the infinite loop of pain and suffering. It's maybe less suffering than what I'm currently doing, but it's a infinite loop of pain and suffering. You change the code, you rebuild images, you tag them, you put the tag in the YAML files, you send them to Kubernetes, and you do that forever and ever. Usually, people solve that with bash scripts and make files. And when you change team, it's always a different set of tools. So the first tool I wanted to show you is Skaffold. Skaffold is a command line tool that you can use to create a very tight feedback loop, locally on your machine or remotely with any Kubernetes. It can be on the cloud, it can be on-prem, it can be Docker desktop, it could be Minikube, whatever. Skaffold will work with it. So who knows Skaffold here? Only a few people? Cool. So Skaffold is a CLI tool, and to use it, you have to describe which artifact you want to build and which YAML files you want to deploy. So usually, you do that with a scaffold.yaml that Skaffold can generate for us with commands like scaffold. If I make mistake, it's going to be even worse. Scaffold init. So scaffold init will create YAML files for us, and once this YAML file is created, I can use commands like scaffold build and scaffold run, and it will do the full loop for me. So it will build the images, tag the images, it will deploy them to Kubernetes, and it will even show me the logs. Let me try to do that. Scaffold init, yes. I would go straight to the scaffold run --tail. So scaffold run --tail builds the images, tags it with my git commit by default. It will put the tag inside the YAML file, send them to Kubernetes, and tail the logs. And Docker Desktop did not start. So I cannot show it to you. I can maybe show it to you with, if I connect to the cloud, at least the cloud is going to work, not my machine. That's fun, right? By the way, thank you very much for staying here. No way. OK, it doesn't work. So scaffold run --tail is supposed to show you the logs, but there's even more. You can use scaffold dev. Scaffold dev will deploy your application and will also watch the file for changes. So as soon as you change a file, it will rebuild the images that needs to be rebuilt, and it will redeploy everything to Kubernetes. So that you have a very tight feedback loop. You can just focus on your code, and Skaffold will just monitor in the background and redeploy what needs to be deployed. It's very efficient in the way it deploys things. I'm not going to be able to show that to you. OK, so funny. So scaffold dev will give you a tight feedback loop, but it doesn't work if your images are very slow to build. Your images, like Docker images, are they slow to build? Only a few people? Yeah? Like a few minutes? Yeah, a few minutes sometimes. So like I change the code, save, and Skaffold rebuilds everything and redeploys, but I have to wait 3 minutes. So it makes no sense. So, and the reason why sometimes images are slow to build is because Docker files have their limit. So Docker files provide Docker build and Docker files provide a very efficient mechanism where it can cache the result of all your layers in the Docker file, but sometimes it's not enough, and you change only something like, for example, here, this is a Java project. If I change one character in this pom.yaml XML, it will have to re-download all the dependencies, recompile all my application, and it's going to take multiple minutes. So this is where sometimes, even with Skaffold, I am not able to have a tight feedback loop. So the second tool I wanted to show you is called Jib. Who knows Jib? Are there any Java developers in the room? Or any JVM language? A bit, yeah, a bit. So Jib might interest you. So Jib is a specialized builder to create Docker images out of your sources, and you don't have to install Docker, and you don't have to write a Docker file. And it will give you a very incremental build that's very fast. So if you change only something in your sources, it's going to rebuild only the strict minimum. And it's going to be very, very quick, much quicker than what you can do with Docker build. Basically, what Jib does, you cannot do with Docker build. You might be able to do it with BuildKit in the future or other kind of builders, but for Java or JVM languages, Jib is very quick, and I'm not going to show it to you. The good thing with Jib is I told you don't have to install Docker. You don't have to write a Docker file. It's just going to be a plugin that you add to your file, to your project descriptor. So in the Java world, you have a Maven, POM XML, or you have a Gradle properties file, and you just declare your plugin, and it's going to build automatically your Docker images for you. Yeah, fast to build. Yeah, more demos. Even skipping the demos is slow. So I wanted to show you that this is not just for Hello World. So you can have like a bigger project with tons of services. You just have to declare all of them in your scaffold.yaml, and each of the services can be a Docker image, and Skaffold will deploy all of them, and will watch the file changes for all of them, and it should work out of the box. It works very well, like locally and remotely. You should really see it to believe that it can be so quick. That's fun. I'm eager to see the video for this talk. Oh, come on. So this is what I wanted to show you. So on my laptop, I have multiple services, and Skaffold is able to watch the sources for all of them, and it will guess what's the best way to rebuild the Docker images when I do a change. Like, it can be just a full Docker build, or it could be just using Jib, or sometimes it can even just sync the files from your laptop to the remote cluster. For example, you're working on a Node.js application. You're changing the HTML or the JavaScript, and maybe you don't need to rebuild the full image when you're developing. So Skaffold can take care of that, and will sync the changes from your local machine to your remote cluster. It will connect to the pod and put the files in the right place, so that you can just focus on your code, and that's it. Of course, don't do that in production. It's just meant for development, but it gives you a very, very tight feedback loop. That was Skaffold. Skaffold, by the way, can deploy using kubectl or Helm. I don't know who's using Helm here. OK, so Skaffold works quite well with Helm, so it tries to adapt on your tooling. So if you're building with Docker, or if you're building with Jib, or if you're building with Bazel, you can use Skaffold. If you're deploying with kubectl or Kustomize or Helm, you can use Skaffold. So you should try it on Monday, and if your machine is OK, it should be very quick to set up and very, very nice. Can it be easier? I don't know. Ask me the question. I don't know. So what I wanted to show you is that, so this was all done in the command line using Skaffold. And you can do better than that if you're a developer and you're using VS Code or Eclipse. You can do that from your IDE. So we introduced a set of plugins for VS Code and Eclipse a few weeks back, and it's called Cloud Code. And I don't know if it's going to work or not. Going inside, yeah, I don't know. So I'm not going to show you. Can we start VS Code? I don't know. OK. That's nice. I'm not going to show it to you. So the idea is that you've got a set of extensions for your favorite IDE, and it will automatically deploy the application for you. No, skip it. So that was Cloud Code for VS Code. You can get it for free. It's not open source. It's just free. You can use it. The idea is to make it, like, in the future, the best Kubernetes plugins for VS Code and Eclipse. And it's going to also help you. Yeah. Yeah, I don't know if the bottles are for the Mac or for me. But, yeah, no, I'm not going to. No. Cool. Funny. Next, I wanted to talk about build. Because building images is very hard, right? You end up with like a big hamburger with multiple layers. Images are too big. They are slow to push, slow to pull from your Kubernetes cluster, slow to build on your CI/CD. And also, there's this big question, like, which base images am I going to choose? If you work for a big company, usually it takes them like 6 months to decide which base images to choose, right? 6 months or 8 months, I don't know, depends. What I wanted to show you is something that is not a Google container tool. I just wanted to do a small recap on multi-stage builds, but maybe you know multi-stage builds. Who knows multi-stage builds? Yeah. For those who don't know, you should really give it a try. If you have to write your own Docker file, it's a way to decompose your Docker file into multiple steps. Each step is focused on one thing and only one, and at the end, the images that you build are much smaller. So for example, here, this is a Java project. So I've got a builder phase and a second phase to run the application. So the builder, I can use, oh no, this is not a Java application, sorry. This is a Go application. So a builder, I can use like a compiler and tooling and lots of things and all the things I need to build my application, but those things, I don't want to ship them in production. So I've got a second phase in my Docker file where I'll just copy the application on top of an Alpine base image, and that produces a much smaller image. And that pattern, you can have multiple steps, and it's very convenient because it will end up with better security in your images, but also it's much easier to choose between different set of base images. For example, you can choose Alpine to run your Go application, or you can choose another type of base images that is distroless. Who knows distroless? Cool. Only a few people. So distroless is a set of base images maintained by Google. They are meant to be more secure. They are meant to be minimalistic. So it's not maybe the smallest images, but it's the base images that contains as few things as possible. They contain only your application and its runtime dependencies. There's no shell. There's no package manager. There's nothing. Basically, it's just libc and your application. And in Go, it's libc, all the libraries to do some SSL, and that's it. And you put your application on top of it. And with Java, it's the same thing, but with a JVM. So we have distroless images for Java, compiled languages, Node.js, Python, and I guess that's it. So it's not a big set of images. So if you don't use any of those languages, you cannot use distroless. But if you do use them, you should really give it a try, because it will give you more secure images. And usually, if you have a multi-stage build, it's very easy to adopt distroless, but I'm not going to show you. Sorry. So that's distroless. Oh, come on. So I wanted to show you also that building on a cluster can be tricky. Who builds Docker images on a cluster? Did you set up, did you mount the Docker socket, or do you run Docker in Docker? For those who don't know, you don't want to know, because those two options, they are not secure, they are not good. It's really, you have to choose between two options that are not good. But if you do Docker build with Docker files, you can basically choose between those two options, and that's it. So I wanted to show you that there's another solution, which is called Kaniko. Kaniko is another tool that you can use to build Docker images with a Docker file. And it will produce a Docker image, standard OCI image that you can deploy to Kubernetes, but without the requirement on Docker. It does not require the Docker socket. It will just run in a standard container without you mounting the Docker socket. So maybe you don't really care, but it means that you can take any Kubernetes cluster and you can build your Docker images on it without challenging the security. Kaniko will get the sources, will get the Docker file. It's basically a re-implementation of Docker build, and it's going to produce an image at the end and push it directly to a registry. And with Skaffold, it's supposed to be very simple to use. You just change your Skaffold configuration, and you say that instead of using Docker build to build your image, you're going to use Kaniko. I'm not going to show that. This talk is called I'm not going to show that. OK, plenty of time to talk about deployment. Configuration hell. So once you've developed, you built your images, you want to deploy them to your production environment, right? And you have multiple environments, like staging, production, pre-production. And usually, this is where Helm is used to produce such Nice templates. Who think this is nice? Like YAML files plus templating. Nice, right? No? You don't like it? You like it. OK, we've got one who likes it. So it's right to like it because you can have ifs and loops, and it's very hard to read so that you don't lose your job. So you're right to like it. By the way, if you don't choose Helm, you can choose between over 60 other tools to configure, to do the same kind of work. Like basically, there are more than 60 configuration tools to deploy to Kubernetes. So it's a little bit of a mess. And very quickly, those YAML files are not very easy to maintain. So I wanted to show you Kustomize. Kustomize is a different way to tackle this same problem. The idea is that you're still going to write some YAML files, but you're not going to write any templating language. You're not going to learn any new language. It's template-free. So how does it work? Basically, let's say I've got a base YAML file. This is the one I'm using in development. This is not the one I'm using in production. In production, I need to add more information. I need to patch a few values. So with Kustomize, I'm going to create patches. This is one of the patches I can write. Here, I'm just going to select the path to the value I want to change. Okay? So there's one value I want to change, and I take all the parents, I remove the rest, and I can just like compress it. And this is a patch. This patch will change that value here, world, to production. Okay? I can have as many patches as I want. Every patch can have like commands. It can be focused on changing one value or multiple values. And using Kustomize, it's going to be applied to my base. It's going to produce a final YAML file. So you can do that with one YAML file, and you can do that with plenty YAML files. And also with Kustomize, you can also change the labels on all your YAML files. And you can change the namespace on all your YAML files very easily without adding any templating to your YAML files. So how does it work? Basically, you have to write such customization here. So I've got a customization.yaml, which lists all the patches I want to apply, which lists all the labels I want to apply on top of my base YAML files, and maybe can change the namespace. So maybe we can try this one. So I've got so this is the base YAML, and I'm going to use Kustomize to produce the end result. Usually it's very quick. See, this is the end result. So it took the base, applied patches, changed the labels, changed the namespace, and that I can use in production. And with Skaffold, this is very convenient because I can create profiles so that if I'm working with Docker Desktop, it will apply the development config. And if I work with a remote cluster on Google Cloud or anywhere else, it will apply the production profile. It will auto-detect which cluster I'm working on, and it's going to just patch the YAML. So that's about it. Without the demos, it's much quicker. So let's recap what I almost showed. I showed you almost Skaffold, which is a tool that gives you a very tight feedback loop on the command line. It's very nice for developers, but you can also use it on your CI/CD pipeline. On Jenkins or any tool, you can build and run and deploy with Skaffold. We tried to show Jib, which is a very convenient way to build Docker images for Java applications. It's very incremental. You don't have to install Docker. You don't have to write a Docker file, so you don't have to learn Docker files. We saw Kaniko that can be used to build Docker images on any Kubernetes cluster without any setup, and it gives you that feature with good security. We tried to show Cloud Code, which is a set of IDE extensions you can use to really focus on your code and forget about some of the complexity that Kubernetes brings you. We saw distroless, which gives you more secure images. And at the end, we saw customize that you can use to customize your YAML files for different environments. And that's it. I'm sure you loved the demo. I'm so sorry. So I came here. I flew here just to give you that kind of presentation. I'm so sorry, but I'm really thankful that you stayed. Thank you very much. So if you want to see this presentation, like with all the demos, I'm sure you can find it on YouTube. It's been recorded multiple times in French and English. And if you have questions, I'm here. If you just want to leave, please leave. Thank you very much.